So to begin, we want to think about what can change your mean arterial pressure. MAP is the average pressure in the aorta during one cardiac cycle. Remember what MAP is equal to. It's equal to cardiac output times total peripheral resistance, TPR. And cardiac output is equal to heart rate times stroke volume. So if I substitute then your equation for cardiac output, which is heart rate times stroke volume, and that's your cardiac output, and I multiply by total peripheral resistance, I have yet another way to determine MAP. So how can we change MAP? Because if I change heart rate, if I change stroke volume, or I change TPR, that will alter MAP. So how do we do that? We're going to talk about two different ways to do this. One of those is by increasing your cardiac output. So here, this is an increase in cardiac output. If I increase CO, that means I have more blood leaving the heart. And when I have more blood leaving the heart, if this is the aorta, then we know when blood leaves the heart, when the ventricles contract, then that's going to cause this aorta to expand outward. So here we're increasing cardiac output. So that's going to increase the volume of blood in the aorta. Remember, the walls are expanding in response to an increased cardiac output. And if we increase the volume of the blood in the aorta, that's going to increase MAP. So just by increasing cardiac output. Now, please notice here that we did not change the total peripheral resistance. There's no vasoconstriction or vasodilation in this instance. Here we are only increasing cardiac output. Again, look at your formula. Cardiac output, if I increase this, that's going to increase MAP. Now, let's try another option here, and that is let's change your total peripheral resistance. Let's increase it, but keep cardiac output constant. So here we have a constant cardiac output, but we are going to vasoconstrict these arterioles. So if we vasoconstrict the arterioles, this vasoconstriction, as we know, is going to increase total peripheral resistance. So remember, total peripheral resistance means the resistance across all of your arterioles at one time. So if we increase total peripheral resistance, that's going to increase MAP. So that gives us two ways to increase MAP. You increase cardiac output, or you increased total peripheral resistance. How do we regulate MAP? So we're going to be using neural and hormonal controls to do that. Here are the two ways to regulate MAP. So you have to keep MAP at a constant, right? You got to maintain homeostasis. You don't want it too high, you don't want it too low. All right, so the two ways to do that are through short-term regulation, which occurs within seconds to minutes, and then there's long-term regulation that occurs within minutes to days. All right, in short-term regulation, this involves baroreceptors. It also involves chemoreceptors, but we won't worry about those with respect to MAP. We talked about chemoreceptors with respect to respiration already. Baroreceptors are located in the carotid sinuses as well as the aortic arch. These baroreceptors are stretch receptors. So they are able to detect stretch, and then they will send action potentials to the cardiovascular control center in the medulla. Hopefully you're asking yourself, well, what will cause them to stretch? Well, pressure. If we change the pressure in the vessels, then that can either increase stretch or decrease the amount of stretch. In long-term regulation, it involves the kidneys. The kidneys then will regulate your blood volume, because if you regulate your blood volume, then we can regulate your mean arterial pressure.